Hey everyone. Can you guys hear me? Yeah. I guess quick survey of the room. Who here has used like Airflow before? Okay, most of the room. That's great. And so yeah, like this talk is going to be like a tale of two tools, Airflow and Ray. I'm Marwan. I'm engineer at Anyscale, and I'll be presenting this talk with Mehul, who's an engineer at Astronomer. So the agenda for today is like high level. When would you want to use something like Airflow or Ray? And then we're gonna showcase like a project that we built but that uses both Airflow and Ray. So we'll go over the architecture of the project. It involves two main components, like continuously updating some data and then continuously updating a model. And then for achieving this project, we've open sourced Ray and Airflow integrations and Anyscale and Airflow integrations as well. So we'll talk about those integrations we've built and how they work. And finally, like for this specific project, we have some key takeaways for you, just in case you're doing something similar. So very high level, like since everybody knows Airflow here, it's just an orchestration tool that helps you like manage your data and AI ML workflows. And so like, for instance, like if you have a model training task, you could use that orchestration platform. But if you want a compute platform, you could use something like Ray, and you could either self-manage it or use something like Anyscale that manages it to run libraries like retrain, retune. So in that context, like Airflow's by now like very good standard for data pipelines. It's has like 25 million downloads, a very big Slack community. And Astronomer is like the driving force behind Airflow. It's basically the company that drives 100% of the Airflow releases and has contributed over 55% of the Airflow code. Overall, like for Airflow, like the use cases for Airflow are pretty broad. Like analytics still being like the top use case for Airflow, but ML and Gen AI like now combined take up to like 41% according to this survey, and that this growth has been pretty significant over the last year of like 24%. And then Ray, probably you guys also know about Ray. Like it's a highly scalable distributed compute framework. Offers you like these Ray AI libraries that are just like high-level abstractions built on top of Ray core, so that you could do different ML workloads like distributed data processing, distributed model training, tuning, and serving. And so it covers the full end-to-end MLOps lifecycle, and it gives you like nice integrations with third-party tools. And Anyscale is like the end-to-end AI platform that like has like an optimized Ray, what we're calling Ray Turbo, and like additional like developer tooling, security and governance, and all the enterprise features that you would want to go along with like managing Ray. At a very high level, what we have built here is like a use case of like fine-tuning LLMs. But basically, like this, like data flywheel is sort of very common in like most like ML use cases where you have some production data that you're building training data sets from, and based on those training data sets, you're fitting models, evaluating them, and deploying them. So really, like there's two parts to this. There's like continuously updating your training data set, which we're calling the continuous data update part. And then there's the part where you're like developing the model, evaluating it and deploying it, and doing that in a continuous fashion. So more specifically, what the data set we've worked with here is user feedback on video games. And we've used an LLM to categorize that feedback. So feedback is usually like just like a natural language. And we're trying to like extract structure from this unstructured data. And the idea here is like, you could imagine that this is being used to like help product managers sort of see what type of feedback is being provided on a given video game. And specifically, like we use this data set called Vigo, where like it gives you like some input, like what is it about games released in 2005 that makes you think it's such a fantastic year for video games? And from that, you can sort of extract a function like request underscore explanation and some attributes like release year is 2005 and rating is excellent. And then the way we achieved this is we used an LLM. We used a Mistral 7 billion parameter instruction fine-tuned model. We used a LoRA technique. And for our evaluation, we looked at the accuracy of how this LLM performed on this task. And we compared this to a baseline LLM that used few-shot learning with like 20 examples. So, so from here on out, we're gonna start talking Airflow and how we like put this together. So Mehul's gonna walk us through this.
Cool, thanks. So yeah, let's jump over to Airflow and we can show off the demo example that we built. So if we go, this is the Astronomer, the Astro hosted product. If we jump over to the Airflow UI, so we have a few dags here, and I think everyone here is, most people are familiar with Airflow, but a dag is directed acyclic graph. It's a series of tasks that have dependencies, and you can run them on a schedule. So the first dag that we want to jump into is this dag called access and transform data. So this starts with reading the data. So this is using a feature in Airflow called task groups, where you can essentially group similar tasks together. So we're reading data from two sources, Twitch and Discord. And this is essentially, we're pulling in that data, and then we're transforming it. So we're using Airflow's dynamic task mapping feature to basically run a task on each of these data sets. We're joining that data back and then uploading it to S3. So that's basically the extract, transform, load stages of this pipeline. Once we upload this data to S3, that actually triggers a dataset event, which is an Airflow feature for data-driven scheduling. So what that does is if we actually go over to this datasets view within Airflow, we can see this dependency graph where this DAG that we just went through, this access and transform data DAG, it triggers this dataset event, and then this DAG, which is the fine-tune LLM and deploy challenger DAG, it gets triggered when this dataset gets updated. So there's a lot of value here, I think, in you can imagine within an organization, it's very likely that this team developing the ETL DAG is different from the team developing this LLM DAG. And essentially the contract by which these DAGs communicate and are triggered is just this data set in between them. So now we can go over to this fine-tune LLM and deploy challenger DAG. So if we go through this, so you'll see this is, again, that data set trigger that kicks off this DAG. And now what it's doing is, the first thing it's going to do is count the number of records and then count the number of records that were written to that S3 bucket. And it's going to check the record count, because if there weren't enough records written to S3, there's no point of continuing with fine-tuning, and it'll just end the DAG. So you can see here on the left side, it's kind of small, but the left side is the first DAG run, and the right side is the second DAG run. And you can see that on the left side, the end DAG task was skipped, and it proceeded with the fine-tuning. And on the right side, the end DAG task was run, and the rest of the tasks were skipped. That's because in the first case, there were enough records to proceed. In the second case, there were not. Anyway, so once we decide to proceed with fine-tuning the LLM, this is where we start to leverage the power of Ray and Anyscale. So the first thing we do is we grab the storage path from S3, and then we have this task called fine-tune LLM. And this is where we're using the integration that we built between Airflow and Anyscale to use this submit Anyscale job operator. I think people are familiar here with providers and operators in Airflow, so we'll jump into that a little bit more detail later. But yeah, the operator here is called submit Anyscale job. And that's executing the fine-tune LLM task. Then we build the application spec, and then we deploy the LLM to Anyscale. And again, you can see here the operator here is called rollout Anyscale service. Then we have a couple tasks that are just tearing down and terminating things that we spun up. Cool. So coming back to the slides. Yeah, so we walked through this ETL DAG in Airflow, the various stages of it, and then went through the data-aware scheduling aspect. And then we talked about triggering fine-tuning. Now, the next step is basically making this continuous fine-tuning, right? So this is where we get to the final goal of the automated retraining. So this here we're showing this paradigm called champion and challenger, where basically you have over here a running service, which is the existing champion deployment. And then you basically fine-tune the challenger, which is your new candidate model. You roll it out, and you run it alongside your existing champion deployment. You have your silent canary challenger deployment. And you can configure it to get X% of traffic. You can configure it to mirror all traffic. There's a few ways you can do this, but eventually what you want to do is you want to evaluate the challenger, figure out if it's better than the champion. And if it is, then you complete the rollout, and you essentially promote the challenger canary to be the primary deployment. And if it's not, then you basically roll back and you alert and you go and figure out why this challenger was not sufficiently better than the champion. So this slide just shows how you could use Ray primitives to do this sort of thing, but what we want to do is do it in Airflow. So if we go back over here, so you can see this DAG looks very similar to what we were just talking about. So within this fine-tune challenger task group, we again have this get LoRA storage path task, and then the fine-tune challenger LLM task, which again we can see uses the submit Anyscale job operator. We deploy the challenger using that rollout Anyscale service operator. We evaluate it again by submitting a job to Anyscale, and then it's all about, then we process the results, and then we decide at the very end whether we should deploy it, whether we should continue with the rollout, or whether we should alert for quality degradation. Yeah, so that's how that DAG looks in Airflow. And now if we come back here, we can talk a little bit more about the integration that we have, right? So on the left side, it's Airflow and Astronomer. The right side is Ray and Anyscale. So again, the goal here is basically to be able to run Ray and Anyscale jobs or services from Airflow DAGs. So yeah, this is the Ray provider that we built. So you can see on the left side an example of how to use the Ray provider. And you can see the operator that's being used is submit Ray job. So how you would use it is you define a Ray spec, which is your YAML file. You specify some attributes of the runtime environment, like your Python requirements, some CPU, GPU requirements. You have a connection ID for your Ray cluster. And that's how you would use the submit Ray job operator. We also have operators for setting up and tearing down a Ray cluster. In Airflow, there's a feature called setup and teardown tasks, where your teardown task will always run even if something upstream of it failed. It's very useful for something like this where you have infrastructure you need to spin down. There's also support for the Taskflow API in Airflow, which is how people can use Python decorators to declare Airflow tasks. So that's, again, the same operator. It's just invoked in a slightly different way. And then there's also an Anyscale provider. So this is what we were showing in the example, but you basically, from the Anyscale provider, you can import the submit Anyscale job operator. Again, quite similar. You have a task ID, a connection ID, and then you can specify your Python requirements and other configuration. And then finally, the rollout Anyscale service operator that, again, we were showing in that example when we were doing the champion and challenger workflow. I think the most interesting part here is this canary percent. That's, again, showing, indicating how much traffic you want to target to this service that you're rolling out. So yeah, key takeaways. So we built a continuous data update flow using Airflow, and specifically Airflow's data-driven scheduling feature. Again, I think that's sort of a best practice, especially when you have these cross DAG dependencies. It's very it's much simpler to use a data set as the dependency there, as opposed to a lot of times you'll see customers try to match-up schedules, like run this DAG at noon and run this DAG at 1 p.m., but that has all kinds of operational issues where if something's late, things don't work as expected. So using data sets is definitely the right approach here. The continuous model update flow, using Ray for the scalable parallelizable compute, for the fine-tuning and deployment. And then finally, the evaluation-driven development, where we have this, we have the evaluation metrics to evaluate the new challenger model, figure out if it's actually better than the baseline or the champion model, and then only deploy it if it's an improvement. And yeah, finally, we have some resources. There's on the Astronomer website, there's within the Astronomer docs, there's a Learn section talking about fine-tuning with Anyscale. And then there's also astronomer.io/Ray, which describes in detail the Ray and Anyscale providers. Yeah, that's all we had. We can just open it up for questions now.
Hi. So I'm doing something pretty similar to what you just illustrated, minus the providers that you showed at the end. But what I've implemented, the DAG is much simpler, right? It uses the trigger, a data-driven trigger like you showed, but then once it's triggered, the downstream logic is pretty much entirely implemented in Python and runs on Ray and uses the Ray head node to trigger all of the additional tasks. So the DAG is a much simpler DAG. I'm wondering, the two advantages that I can see from your approach, number one is implementing disparate code. I have control of all my codes, so I don't need to pull in code that other people have written here. And then number two, your complex DAG provides for more tightly controlled retry logic if certain parts of the task fail. Well, my question for you is, are there other advantages that I'm failing to appreciate for why you would want to have most of that flow controlled in Airflow and not within the script that Ray is running?
You want to take it? Or? So I think retries is definitely one of the big reasons. The other thing that you might everyone heard the question, right? Cool. Yeah, retries is the biggest thing. The other thing you might run into is I showed like that dynamic task mapping thing. So you eventually might want to scale out some of those individual parts of the workflow on some vector as well, which you might want to use something like dynamic task mapping as well. And the other thing could be maybe it's not an issue because you could run it in Ray, but if you have specific compute requirements of different tasks, Astro has a feature called worker queues where you can assign different tasks to different worker queues, and you can say like this task needs X amount of CPU versus that task needs X amount of memory, etc.
I also wanted to add so those providers we showed, they're all open source, and the way we've implemented them is sort of like best practices on deferred submission of basically when it runs the job, the worker is now sort of free to go and trigger other things. So that deferred polling is a nice thing that you don't have to implement yourself. So if you just sort of install, whether it's the Anyscale provider or the Ray provider, they both sort of work the same way. Instead of having to trigger something and sit there and wait and block your Airflow worker, that's one nice advantage of it.
Is that best practice implementation also, is it illustrated in open source?
Yeah, so they're called the Anyscale provider and the Ray provider. They're under the Astronomer repo right now, and we're trying to promote them to be part of the Airflow, the open source Airflow providers. And yeah.
Thank you.
All right, my question is about 1 or 2 years ago, there was already a Ray operator in Airflow, which was stopped maintaining by Anyscale. At the time, I think the provider was Anyscale. My team has been using it, and it put us in the awkward situation that we cannot support it in production anymore, and it's not working. So the question is really about why that one was stopped and why this one gets started, and what's the difference between the two?
Yeah, so I only been with Anyscale for a year, but I did hear about we used to have something for Ray and Airflow. So what we built there, okay, so there's two things here. Like there's the Anyscale integration, which is basically calling the Anyscale SDK to like create jobs and services on the Anyscale platform. And so that would be like very useful to you if you're already using Anyscale. And then the Ray provider, I feel like they're like the idea is sort of an update to the more recent versions of Airflow. That's my understanding. I don't know much about the Ray provider other than like it's an update that supports the TaskFlow API and so forth. That's.
So does that mean the Astronomer, like Airflow provider, is more like the old one that we had previously? That's just gonna, that one was pretty much just submitted jobs, and like this one, is that the same?
Yeah, I think the new one has a lot more features. It takes advantage of a lot newer Airflow features, like Marwan mentioned, the deferrable operators, as well as I think I mentioned setup and teardown tasks. Those are both relatively newer Airflow features that would not have existed at the time of the old provider being written.
Okay, I see. And is this one going to be working at both open source Airflow and also some closed source one like Google Cloud Composer, something like that?
Do you know if it works for Google Cloud Composer?
Yeah.
It works with Composer, yeah.
Okay.
It's just right now it's not yet in the OSS Airflow repo, so I think it's in the Astronomer. It's a repo in the Astronomer org, but I think the goal is to move it into.
The goal is